All right, so just in case you were gone on Monday or you were in a class period where I was unable to teach, here is the lesson that we went over for combining like terms and the distributive property. So to get us started, we have on the combining like terms, we have three arrows up at the top. This first arrow is pointing to the 3. The 3 is a coefficient. Coefficients are numbers with letters. So, definition, numbers with letters. Middle arrow up at the top is pointing to the 5. That is a constant. Constant definition are going to be numbers without letters. And then our last arrow here is just pointing to the X, and that is a variable. Variables can be any letters that you want. Definition is it's a place value or a placeholder. It's the unknown. It's unknown and represented by a letter. Any letter you want. So, and typically that is what we are trying to find if we are solving. Okay. Underneath the 3x, the 5, and the 6x, we have a blank for each of those, and that is because they are called terms. 3x is a term, 6x is a term. 5 is also a term. Terms are separated by addition signs or subtraction signs. That's how you know where one term starts and the other term ends. Terms can be combinations of coefficients and variables. They can just be constants. They can also just be a variable. They can have exponents. It does not matter. Lots of things. But once you start adding and subtracting, then the term gets split up. Terms can have multiplication and division in there because we show multiplication just as numbers with variables, and we show division as a fraction. And those are okay to have within a term, but you can't have a term that also includes addition or subtraction. Okay. The last two arrows are pointing to the 3x and the 6x because those are what we call like terms. And definition for like terms must have. So, oops. Terms that have exact matching variables. Is our definition for like terms. Terms that have exactly, maybe it should be exactly matching variable. So 3x and 6x both have an x. They are exactly matching and therefore makes them like terms. Okay, the whole thing, 3x plus 5 minus 6x is what we call, I have not used blue, the navy blue, an expression. Expressions are combinations of terms with addition and subtraction. Expressions do not have equal signs. Okay, so a lot of vocabulary up there, but you should have heard those words before. When we are combining like terms, there are 3 steps. Step 1, step 2, step 3. Step 1, we're not really doing any math, but we are in fact identifying the terms that are like. I like to do this, I like to go through and like I'll circle one set of like terms. And I am, even though technically the minus is not part of the term, I'm going to go ahead and group it because it tells me like the plus and the minus that do separate the terms go with the term that's right behind it. Okay. So, and that's important when we get to step 2. Okay. So I like to circle like all the terms that have X's. And then, I might go through and be like, oh, 5 is a constant, so I'm going to put a box around it. And so if there were other constants, I would put boxes around those. If I had terms that had Y's in them, I would, I don't know, use some other symbol like a triangle or something, or maybe just underline them. You could use different highlighting. It's just something to visually represent that they have different terms besides just the fact that the letters. Okay. Step 2, we're going to rewrite the expression. So that the like terms are next to each other. Okay, so we took this minus 6x and we moved it in front of the plus 5. So notice that it's still a minus 6x and the 5 is still a plus 5. Like those, it did not change the signs. I still have a 3x, I still have a minus 6x as my terms. Okay, so those pluses and minuses stay with the term that's directly behind it. Okay, and then step 3, we are going to combine the groups of like terms. Together to make a simplified answer. So for terms that have variables, you're just looking at the number. So we took the 3, the coefficients. We took the 3 and then the minus 6, and that is what gave us a negative 3x. So the x, the variable, is not going to change. You're just combining the coefficients. And then down at the bottom here, we have some just notes for you to keep in mind. So if there's only a variable, meaning that there's no coefficient with the variable, then that coefficient, the number in front of it, is 1. Mathematicians are lazy. We don't like writing the number 1 if we don't have to. Just like we don't like writing the multiplication between the number and the letter. But that is what's happening. Whenever you see a number next to a letter, next to a variable as a term, they're multiplying each other. We just don't write multiplication. The second note we have is when we are combining like terms, and you might have a distributive property in there, some distributive property. Fear not. We must use the distributive property before we combine our like terms. And that is like guided practice number 2, right here. Okay. So I'm going to do guided practice number 1, and then going through steps 1, 2, and 3. And we'll look at the distributive property on the backside before we can do guided practice number 2. So for step 1, Identify our like terms. So I have an x and I have a 3x. Those are like terms. I have a -1 and a +2. Also like terms, they're both constants. They don't have any variables. Step 2, rewrite the expression so that my like terms are next to each other. So I'm going to write my x terms first. So x plus 3x. And then -1 plus 2. Step 3, I'm going to combine them, but it's just a variable. So if there's only a variable, the coefficient is a 1. Okay, so I like to add my 1, and then I'm going to take that 1 and the +3. So I have 1 plus 3, that gives me a 4. But the x is still there. Like, we can't not write the x. And then I'm going to do my -1 plus 2, and that is a 1. That equals 1. The 1 is positive. Like, I have two separate terms here, right? It's not 4x1, because that would look like 4 times 1, which would just be 4, and that's not what it is. This is a 4x and a 1. The 1 is positive. So remember, we separate terms with plus signs and minus signs, right? Isn't that what I said up here? Terms are separated by plus signs and minus signs. So if you don't know what symbol to use, you have to look at what the second term is. And is it a positive number? If it is, you're going to use a plus sign. If the second term is a negative or has a negative coefficient, then you're going to use a minus sign. And that is it. We can't do anything else with 4x plus 1 because 4x and 1 are not like terms. Yes, they're all numbers, but they're not the same type of numbers. Like 4x is an apple, 1 is an orange. They're both fruits, but they're not the same type of fruit. Okay, guided practice number 2. Oh, I don't know how to work with this second part, so I'm going to look at my distributive property and see what I can make sense of from that. So distributive property, to distribute. This is one of the classic math definitions. To distribute an algebraic expression, use something that is called the distributive property. Doesn't really tell you a whole lot. But if you are distributing something, you are passing it out. Like when I distribute papers to the class, I make sure every single student has a paper. I am distributing the paper. So the distributive property is distributing a number to everything in the parentheses, typically by multiplication. Okay, so then after the distributive property is used, the new algebraic expression will be equivalent. That just means same. To the original expression. Okay, so then let's look at this example. We have a 3. And then we have arrows drawing. So that started off with a 3 times the parentheses, -2x plus 4, close the parentheses. What the distributive property says is we're going to take the 3 and we are going to multiply it by each term inside the parentheses. So I'm going to take my 3 and I'm going to multiply it by this -2x. And that is where this comes from. It is being multiplied. 3 times parenthesis -2x. Then I'm going to take my 3 again, and I'm going to multiply it by a +4. The plus sign goes in between, mainly just because also the 3 is positive, the 4 is positive, so I know I'm going to get a positive number, therefore plus sign. Quite honestly, you can always just put a plus sign in between your terms and then figure out whether the term is positive or negative and go from there. Okay, so then 3 times positive 4, that is where this comes from. And yes, we are multiplying. So when you're multiplying constants with coefficients, you just multiply the numbers. 3 times negative 2 gave us the negative 6. The x comes along. 3 times 4 is 12. That 12 is positive. That is why there's a plus sign between my negative 6x term and my 12. And again, I can't do anything else because negative 6 has an x, 12 does not. They are not like terms, therefore I cannot combine them. Okay, let's look at these problems. Guided practice. So I'm going to take my 2 and I'm going to multiply it with the negative 4. So I'm first going to show 2 times negative 4. Normally, I'm not going to put the dot between it, but since this is our first time doing distributive property, plus sign, then I'm going to take my 2 and multiply it with my second term in the parentheses, which is a positive 3x. 2 times negative 4 is a negative 8. 2 times 3 is 6. The x comes along. 6x is positive, so plus sign goes between my negative 8 and my 6x, and I'm done. Okay. In class, we talked about how to deal with fractions. So on my calculators that you are allowed to borrow, not take, I'm still missing some calculators in the back of the room, and I'm going to remove the calculators if people do not start returning my calculators. But there is a button that looks like an ABC, and that is the fraction button. Okay. Guided practice number 2. We have a fraction. So as I was saying, if you're borrowing one of my calculators, you're going to look for the 7 button on the calculator, and then there's like 2 buttons, and then there's a button that says ABC, AB/C. That is your fraction button. That allows you to type in fractions on the calculator and do like crazy math with it. Okay, so that's what we're going to do. We're going to use that button. But aside from that, everything else still works the same. I'm going to take that 1/2 that's out front and I'm going to multiply it by 2x. So I have 1/2 multiplied by 2x. The minus sign is just going to be brought down. And then I'm going to take the 1/2 and multiply it by 4. So then in the calculator, I would type in 1 and then the ABC, AB/C button, and then 2. And then that is going to look like on my calculator screen, there's like this backwards L once you press the ABC button, 2. So that is the 1/2. On your calculator screen, when you see 1 backwards L 2, that is a fraction of 1/2. Okay. Then to continue on, we're going to say multiply by 2, and the calculator screen would show multiply by 2, and then you say equals, and it tells you all of that is equal to a 1. So we have a 1 with the x. Oh, we are going to repeat that process. Minus, again, just bringing that minus sign down. 1/2 times 4. So 1 AB/C half times 4 would look like on my calculator screen 1 backwards L 2 times 4 and equals the calculator is going to say that's equal to 2. Done. So this button up here is like the golden button when you're working with fractions. Just want to put it out there. You are allowed to use it. You still have to show your work, and showing your work, like this is showing your work, writing it out as to what I'm multiplying in my calculator. Okay, that is what you're having to write if you show your work, this step. Okay. All right, so there is one more example. I skipped guided practice number 2 on the side that was combining like terms because it had a parenthesis, and parentheses mean distributive property. So I have to do the distribute. I have to distribute before I combine like terms. So I have to do this first. And I'm going to include that plus sign with my 3. Okay, so I'm not going to do anything with this negative 5x. I'm just going to keep on writing it until I actually get to my combining like terms. Don't want to do that yet. Okay, so negative 5x. And then I'm going to take my positive 3 and multiply it by, so taking my positive 3, multiplying it by 6. Then I'm going to take my positive 3 and multiply it by 7x. And again, that plus sign. So positive 3 times 7x. So showing my work. Still showing my work. Negative 5x. 3 times 6 is 18. Plus sign, 3 times 7 is 21. The x comes along. So there's our distributive property. So I did this step. Check. Now I have to combine like terms. So I need to first identify what my like terms are. And again, I have a 5x. I have a 21x. Those are like. 18 has no other constant to pair with. So I'm going to rewrite my like terms next to each other. Negative 5x plus 21x. I said 21, and yet I wrote 12. And then plus 18. Combine my like terms. Negative 5 plus 21 is a positive 16. X comes along. 18. Nothing's happening to that. So plus 18, and that is my simplified equivalent expression to what I started with. I can't do anything else. It's not like a 34. It's not a 34x. It is 16x plus 18 because 16x and 18 are not like terms. Groovy. All right, so that will hopefully help those of you who are going to work on Monday, or, well, your class was just too loud and obnoxious for me to do my job. So good luck, and I will talk to you later.